Hi everyone. So this video is on seasonal adjustments. Seasonal adjustments. So they're part of Further Maths, Unit 3, and it is part of your data analysis core study, and in particular, investigating and modeling time series data. So hopefully by the end of this video, you will be able to perform a seasonal adjustment to time series data and also understand the use and interpretation of seasonal indices and how to calculate these. So, why do we need seasonal adjustments? To help us observe the trend of the data, it is often necessary to make seasonal adjustments. These adjustments enable us to compare different seasons and then help make predictions more reliable. So, undertaking a seasonal adjustment. The first step is to plot the time series data that's given to you in the question. So each of these points will be given to you in the question and you have to plot them, or in some cases, they'll actually give you this entire graph. So from this graph, we can see that there are seasonal characteristics. It peaks every third quarter, and then it has a trough every fourth quarter. So there's some sort of pattern, seasonal pattern going on here. So we need to undertake a seasonal adjustment. So the second step is to find the average of the quarters for each of the years. So this is obviously calculated by adding the values for each season together and then dividing by the total number of seasons. So here, for example, for the year 2007, we take the value for each season, add them together, and then divide by 4 because there's 4 seasons. And we do that for each of the years. Then we can construct another table to establish the quarterly proportions of the number of purchases. So this is calculated by dividing the actual sales figures, which are given above, by the quarterly average for the respective years, calculated in step 2. So in this table above here, we're given the value of 920 for summer of 2007. So we take that and we divide by 923, which we calculated before as the quarterly average for this year. That gives us a value of 0.997. We do that for each year and each season. So then, to find the seasonal averages for each season, and these are our seasonal indices. So these are calculated by adding the same seasons together and averaging in them. So in our case, we add each season and divide by 3. So if we just go back to the previous slide, we can see for summer, we're adding up 0.997, 1.007, 1.098, and dividing by 3. Now we do that for each season. And it's important to note that the seasonal indices will add to 4 because we have 4 seasons. So a good way to check if you've done this question right is to make sure these add up to 4. And if they don't, you've done something wrong. And these seasonal indices give us important information. So for example, a value of 1.03 for summer tells us that sales in summer are typically 3% above the average. However, if we have a value below 1, which we do down here for spring, we have a value of 0.52, and that tells us that sales in spring are typically 48% below the average. And this is important as well because often in the multiple choice, they'll ask you for questions like this, or even sometimes they'll give you a value and then they'll ask you to interpret it. So you pretty much just write this exact sentence, changing the values, obviously. So step 5, we need to deseasonalize the data. So we divide each term in the original time series data by its seasonal index. And this gives us the seasonally adjusted, or sometimes known as deseasonalized, time series. So we take here for summer 2007, our original value of 920, and we divide that by our seasonal indice for summer, which was 1.03. We do that for each season and each year. And then step 6, we can plot the seasonally adjusted values, which we calculated just here, on the same axis as the raw data in step 1. And another little note is we use these seasonal indices to remove the seasonal component of the time series data. So that's another little good interpretation there. Step 7. So once the data has been deseasonalized, we can fit a trend line. So we will use the number of purchases, but it's important that we're using the deseasonalized data this time as the dependent variable, and the time period, which in our case is from 1 to 12, so we have 12 periods, as the independent variable. So the deseasonalized data is clearly more linear, as we can see from this graph here. And then we calculate our least squares regression line in the normal way. So in our case, this is our line, and this is our least squares regression equation down here, where summer 2007 has an x value equal to 1. So step 8 is predicting. So we can use our equation above that we calculated just before to make predictions. So this will involve interpolation, which is for values within the range of our original data set, or sometimes extrapolation for values outside the range of our data set. So for example, we can use this to predict how many items might need to be ordered for the autumn 2010 season. So that's because that's outside our original data set, this is an extrapolation. So we take our equation, and since autumn 2010 will be quarter 14, we substitute t equals 14 into the equation. So here we've calculated our deseasonalized purchases. Now it's important that we don't round this value yet because we're not finished. This figure gives the deseasonalized value for that time period. So we want to calculate the actual predicted value. So to do this, we multiply by the appropriate seasonal indice. So for autumn, that was 1.15. So we take our value here for our deseasonalized purchases and we times that by 1.15. And we can say that we expect approximately 1,595 sales in autumn of 2010. So just some final tips. Seasonal adjustments are for time series data that have a clear seasonal trend only. And the best way to practice this is just using past papers, which are available on the VCAR website from your school, and any past SACs that cover this unit.